Yes, it's Uncle Jegs, and it's all about the electrolysis required practical today. I ain't even gonna front, today is pretty heavy with the theory, so make sure you've got your revision notepad ready. I'll first jump on ionic compounds before looking at the theory of electrolysis. Then I'll touch on the redox reaction, and also we'll be looking at them lovely half equations. Then we'll be ready to look at the required practical itself. As always, check the description to chop the worksheet for this session and also to get the answers to the previous video's worksheet as well. Okay, let's keep that. There are three types of bonds that you need to know: metallic, covalent, and ionic. We will be focusing on ionic this lesson. These form when a metal and a non-metal react together. Let's take a quick detour and look at their atomic structure. Atoms are made up of three subatomic particles, sub meaning below. We've got protons, which have a mass of 1 and have a charge of +1. These are located in the nucleus. Neutrons also have a mass of 1, but they have a charge of 0. They are also located in the nucleus as well. And finally, electrons have a mass of 1/1830, but you can just say very small if you can't remember that number. This is an atom of helium here. It has 2 protons, 2 neutrons, and 2 electrons. That is 2 positive charges in the nucleus and 2 negative charges in the shells. Therefore, the atom has an overall charge of 0. Now, ions are particles with charges. In chemistry, the nucleus stays the same, so we're not changing the protons. So the only way to change the charge is to make an atom gain or lose electrons. Removing an electron makes the helium atom turn into a 1+ ion. That's because we've got 2 protons now and only 1 electron. But if we gained electrons, so I added an electron, it will be a 1- ion. That's because we have 2 protons but 3 electrons. Positively charged ions are called cations, and negatively charged ions are called anions. I remember the cations because the T in the cation looks like a positive charge. So I just remember cations are positively charged. Okay, now back to metals and non-metals reacting. Metals tend to form cations, so they lose electrons to become positively charged. Non-metals, on the other hand, become anions, so they gain electrons. Okay. The number of electrons that an element gains or loses is related to its group number on the periodic table. Atoms want to have a full outer shell. Group 1 has 1 electron, so it's easier to lose 1 electron than to gain 7 electrons. Group 2 have 2, and it's easier to lose 2 than to gain 6 electrons. When you get to group 5, they gain 3 electrons rather than lose 5 electrons, and all the way to group 8, or sometimes they're called group 0, they don't lose or gain electrons because they already have a full outer shell. Putting all this into practice, we have sodium chloride. Sodium is in group 1, so it loses 1 electron to become a cation with a plus charge, 1+ charge. And that electron goes to the chlorine, so that gains 1 electron, becoming an anion of 1 negative charge. So what about something like magnesium chloride? Well, magnesium's in group 2, so it's going to lose 2 electrons, and chlorine's in group 7, so it's going to gain 1 electron. That means you need 2 chlorine atoms in this reaction, each one gaining 1 electron from the magnesium. When ionic compounds are solid, they form structures known as giant ionic lattices. You may have seen that solid ionic compounds don't tend to conduct electricity, but if you dissolve them or melt them, they conduct electricity. The reason for this is that while they're solid, the individual ions are unable to move around, so they're unable to carry an electric current. But when you melt them, they turn into a liquid that can flow, and if you dissolve them, the individual ions are free to move around. Okay, now you're ready to fully deep electrolysis. It literally means breaking down a compound using electricity. To perform electrolysis, you need a way to direct your current into your substance. We use electrodes, which are just made from graphite. One is positive and one is negative, depending on where we connect it on our power pack. There are two ways to remember the names of your electrodes. The simple way is just to remember PANIC, P-A-N-I-C. This stands for positive anode, negative is cathode. The more trickier but detailed way to remember this is to think of the names. Remember that cations are positively charged and anions are negatively charged. Now look at the charges of our electrodes. Where do you think the positive ion is going to go? Where's the cation going to go? It's going to go to the negative electrode, of course. And the negative ion, the anion, is going to go to the positive electrode because positive and negative attract, opposites attract. The positive cation goes to the cathode, the negative anion goes to the anode. Ode means light, so the cathode likes cations and the anode likes anions. Here's where it might get a little bit tricky. Depending on how you prepare your electrolyte, which is just the name of the substance that is broken down during electrolysis or as liquid, you get different substances. If you just melt your ionic substance, then it's light work. Your cation forms at a cathode and your anion forms at your anode. If you've got sodium chloride, the cation is going to move towards the cathode and the anion is going to move towards the anode. So the sodium, which is our cation, is going to move to the cathode, and the chloride, which is our anion, is going to move to the anode. But if you dissolve your ionic substance, you are introducing water into the equation. Water splits into hydrogen ions and hydroxide ions. As you can see here, we have an issue. If we have a solution of sodium chloride, we have two cations and two anions. There are two important rules to work out what is formed at your electrodes if you're using a solution. For the cathode, we need to look at the reactivity series. Look at the first rule. If the metal is more reactive than hydrogen, hydrogen is formed instead. So looking at the reactivity series, we see hydrogen's over here. And our metal is sodium, which is more reactive than hydrogen. So following the rule, hydrogen is formed at the cathode because it's less reactive. Instead of memorizing all of the reactivities of the different metals, just remember that copper will always be formed since it's lower than hydrogen. And it's easy to remember the other three because silver, gold and platinum are definitely less reactive because they're used in jewelry for that reason. Now what about the anode though? Well, if the anion is not in group 7, then oxygen is formed. You seriously don't need to know why, but I'll just sprinkle a little fact here. It takes less energy to form oxygen than to form the other substances that you might have. But our chloride ion is a halogen ion. We call halogen ions halides. That's why this isn't called a chlorine ion, it's called a chloride ion, okay? Because it's a halide. And since the chloride is in group 7, that's what's formed at your anode. I've got this example here. What will be formed if we electrolyze a copper sulfate solution? The same solution we made in the last video. Pause the video and write down all of your 4 ions in the solution and use the 2 rules to work out what is formed. Our 4 ions are hydrogen and hydroxide ions from the water, and then copper and sulfate ions from our electrolyte. Looking at the first rule, copper is lower than hydrogen, so copper is formed at the cathode. But look at the anion, it's not in group 7, so oxygen is formed instead. Okay, I beg, do not be angry with this one. Half equations can look a bit nuts, but just bear with me, alright? The first thing to realize to understand half equations is that you are not forming ions. You're forming the atoms or the molecules. So the ions have to turn into atoms or molecules. Let's look at copper chloride. Since it doesn't matter if it's in solution or molten, it will always obey the cathode and anode rule. We start off with the cation, which has a 2+ charge, and we end up with a neutral atom. And our anion, we have a -1 charge and we have a neutral molecule forming. So for our equation, we have a copper 2+ ion and chloride negative ion forming a copper atom and a Cl2 molecule, a chlorine molecule. Let's first balance this. I have one copper on the left hand side and one copper on the right hand side, but I have one chloride ion on the left and two chlorine atoms on the right. So I need to put a big 2 in front of the one on the left, which then tells us that we have 2 moles of chloride ions to make one chlorine molecule. Half equations are called half equations because we split the equation into half. We focus on one species at a time. So first I'll look at what happens to the copper. We have a copper 2 plus before the arrow and then just a copper atom on the right hand side of the arrow. So we go from a plus charge to a neutral charge. To get rid of the 2 plus charge, I need to add more negative charges, so I need to add electrons, 2 to be exact. This is what happens at the cathode. The cation gains electrons. Now for the other half of the equation, we have 2 chloride ions on the left hand side and 2 chlorine atoms which form a molecule on the right hand side. Obviously each of the chloride ions need to lose an electron, so then we need to get rid of 2 electrons on the right hand side. But we are not done yet, we're not done yet. You also need to be able to classify half equation into either oxidation reactions or reduction reactions, okay? Oxidation is the loss of electrons and reduction is the gain of electrons. If you remember oil rig, then you've got this on lock. Oxidation is the loss of electrons, reduction is gain of electrons. In electrolysis, metal ions are always gaining electrons, so they are always reduced. The anions are always losing electrons, so they're always oxidized. Alright, it's practical time. There are various ionic solutions that you can use for your required practical. For this example, I'll be using copper 2 chloride and sodium chloride, alright? I'll be electrolyzing each of these separately and then recording my observations in a table like this one. First, we pour like 50 centimeters cubed of our copper 2 chloride solution into a beaker. Then I add the electrodes into the solution. The 2 electrodes should not be touching. Next, you should connect your wires to your electrodes using crocodile clips. Then you make sure that your potential difference is on 4 volts. Only then do you switch on the power pack. Look at both of your electrodes and then record your results. You should see something that looks like this. Use forceps to hold a damp blue litmus paper next to your anode and then record your results. Repeat your steps with the other solutions and then record your results. I'm just going to stress some of the safety precautions for a bit. If you're using chloride solutions, you're going to produce chloride gas. This is the same gas that was used in World War I because it dissolves in water in your body to make hydrochloric acid. This is all fine if it's in your stomach, but it gets to your lungs before all of that happens. So you need to make sure that all the windows are open and you don't leave your experiment running longer than 5 minutes to reduce the concentration of chlorine gas in the air. Your results, if you use the same chemicals as me, should look like this. Notice that the anode, which is positively charged, not only produces bubbles, but it also bleaches the damp litmus paper. This tells us that chlorine gas is forming. Since copper is less reactive than hydrogen, that's what's formed at your cathode over here. And hydrogen is formed here because the sodium is more reactive than the hydrogen. There we go. Electrolysis required practical. You know what to do. Scroll down to the description to chop today's worksheet and also the answers to the previous video's worksheet. Like if you like, sub and turn on notifications if you're down, and yeah, in a bit.